And now the last of our three-part series on absolute value inequalities, I just want to talk briefly about these two cases because they do happen once in a while. You might get no solution for an answer, which means you graph nothing, or you might get all real numbers for a solution, which means that everything works. I want to just show you two examples, one for no solution, one for all real numbers, so you've seen how it works and why that happens. That might help you then when you complete your homework, complete your assignments, take your quizzes, take your tests, and all that good stuff. But before I do that, I'll show you something really, really easy. Let's say I have the absolute value of x, and I'm going to say it's less than -1. So what I'm saying here is that the distance from 0 has to be less than -1. So think about this. Is that possible? Can I actually have this where my distance is less than -1? Well, the answer to this question is no. Your distance can't be negative. So if I see something like this, that means right up here in red, no solution. If you got this in your algebra work and you're left with the absolute value of x is less than -1, that would be no solution. Different example, if I had something like this, where the absolute value of x was more than -3, so what we're saying is the absolute value of x, the distance from 0 has to be more than -3. Is that possible? Well, of course it is. My distance, the lowest it can be is 0. If I'm right on top of something, if I'm at 0, well then I'm 0 spots from 0. So my distance is always, always, always more than -3. If you get something like this, it's all real numbers. Another case, if you had something like this, the absolute value of x is more than or equal to 0. Well, again, my distance is always at least 0. So that's always going to work. Whereas if I have like the absolute value of x is less than 0, well, my distance can't be less than 0. So that is not going to work for anything. If I had less than or equal to, well then I'd only have one answer, 0, because that's equal to. But if I take away that equal to, then this will also be no solution, hence why I put it in red. So my first example for this quick video, -3 times the absolute value of 2x minus 4 is more than 12. What's my first step? Think about it for a second. My first step would be to divide by -3. Because, again, I can't do anything until its absolute value is all by itself. So you divide by -3, divide by -3. So I do this, and I get the absolute value of 2x minus 4. That's the absolute value, right? Not 12x. So I'll make this clear. It's the absolute value bars. That is less than -4, right? Divided by a negative. So that sign is going to flip around. Reverse, reverse, reverse. Okay, here I am. The absolute value of something, some distance, is less than -4. The smallest my distance can be is 0. So just seeing this right here tells me no solution. If you want to make your two inequalities and solve it and then plug them in and check it and see it nothing works, we'll go right ahead. I'll tell you right now, I'll save you the trouble. This will have no solution. So I'll go to the next example here, one that has all solutions. This will be example 2 of 2. So here it is. The absolute value of 3x, that plus 4, is more than or equal to -12. So I'm going to solve this one just all the way out so you can see what happens here. So first I do -4 because I want the absolute value bars by themselves. I'm going to keep repeating that over and over again because I want to drill this into your head. So then I have the absolute value of 3x is greater than or equal to negative 16. So, excuse me, if I make my two inequalities, well, here's one. 3x is more than or equal to negative 16 with greater than, that's or. So, or 3x double switch less than or equal to positive 16. So now what I'm left with, when I divide both sides by 3 to both inequalities, is x is more than or equal to negative 16 thirds, it's basically negative 5 1/3, or x is less than or equal to positive 16 thirds. So I get this when I solve it. So I'm going to show on a graph what this actually means. So I've rewritten the answers, and yeah, I'm using my iPad and stylus, and the handwriting still looks pretty bad. But I mean, come on, is it really any worse than what I put on the board every day in class? I mean, let's be honest, not really. So anyways, if I go and graph this, what I'm saying is, I'm going to first mark these points, negative 16 thirds, and then 16 thirds. So 0 is like right there, basically. So x has to be more than or equal to negative 16 thirds. So that's a closed-in circle, because it's equal to. And I go this way. And then, or x is less than or equal to 16 thirds. So closed circle, it's less than, I go that way. Here's the thing though. I use or. Remember, or means that if either one is true, this one or this one, I shade it in. So I don't just graph in between the 2 points like this if this was and, because if I plug in, let's say like 10's out here, if I plug in 10 to x, 10 is more than negative 16 thirds. Let me just erase this and rewrite this. So that's going to be true. So I do graph 10. In fact, I graph everything over here because everything from this point onwards is more than negative 16 thirds. Likewise, if I had negative 10, I know that negative 10 is less than or equal to 16 thirds. After all, it's negative. It's got to be less than a positive number. So anything left of 16 thirds will get shaded. So all this gets shaded too. So I shade everything. This means my solution is all real numbers. Or more specifically, x, I can put equals here. You know, x equals, well, anything real. So any actual number. And maybe you're asking yourself, why do you keep saying real numbers? Why not just all numbers? Well, sorry to upset you, but at some point in Algebra 2, you can ask your friends in pre-calc right now, there will be imaginary numbers. Don't worry about that now, but just to let you know that will happen at some point. So we specify all real numbers, not just numbers. Okay, that's it. Adios.